Hey guys, welcome to the video. So I'm currently in Sète. It's a small city in southern France near Montpellier, and I was here for a scientific conference. It's a beautiful place actually, just beside the sea, and our resort is just facing the sea, and it's beautiful as you can see. But it's pretty windy right now and a bit cloudy. So something important came up in the conference yesterday, and I thought I'd make a YouTube short. It's a very important question. So if you think about it, all of physics is kind of modeling, and like from I'm talking about everything, every physics, like from Newton's laws to the kind of complex stuff we do today. It's kind of modeling. Now there are two ways you can model stuff. One is the, let's say, the usual way. You start with an analytic, like you start with an equation and you solve it. You try to plot it. You get an analytical prediction, and then you try to fit it with real experimental data and see how whether it works, whether it explains the data. And there's also something which we might call the data-driven modeling. So it's more of a recent trend, but not really if you think about it. Kepler and all, the very old, like even before Newton, what Kepler did was he collected lots of data. Kepler, I think Galileo with the telescope of the planets, orbits, and astronomical stuff. And then what they did was they collected data and then they proposed an empirical law, right? So it was kind of data-driven modeling in a very primitive sense, but it was. So yeah, in data-driven modeling, you start with the data and you try to maybe you try some optimization, like maybe minimize free energy, maximize, or in some cases you don't even care about physics, like any physical terms like energy. We just see where you just have like an abstract mathematical parameter space and see where that takes you. Try to optimize stuff. So and it's not really a question of which is better. It depends on the context. But there are problems. I mean, there are limitations with both, and I think as physicists, it's important to acknowledge the limitations. So, for instance, if you start with a very analytical model, so first of all, you cannot be sure that you will always find such a model. There is always a possibility you won't. If you're lucky, you will. But and if you can't find a model, you can't even prove that such a model cannot exist. It depends. You can try by adding correction terms to equations. You can try tweaking, and that's what we do usually. And if it's about data-driven modeling, well, again, first of all, you have the quality of data which you have. That's always a problem. Whatever kind of modeling you do, it's always a problem. Like there's always experimental limitation stuff. So I think physics is like inherently physics is like just about building models of reality. It is not reality. So, but yeah, this was something interesting, and I thought I might like share this with you. So yeah, thanks for watching, and yeah.